This video will demonstrate how to configure the Nortec 600 for fastener hole inspection. The Nortec 600 offers several distinctive features. It has a menu of application presets, so you can configure the instrument with the push of a button. There is no need for filter adjustment. New filter settings ensure constant figure 6 and figure 8 signal shapes. The new length function automatically readjusts the filter settings to compensate for changes in the RPM control, and it is compatible with all major aircraft manufacturer procedures. Although the Nortec 600 can be configured in various ways, the following method is the fastest way to obtain good signals and consistent results. When you connect the scanner to the instrument, a menu appears. Press Continue. With the latest software revision, the application selection menu should pop up automatically. Select Bolt Hole and then press Accept. Press the main key and enter the correct test frequency. The default has been set to 500 kHz. Before you turn on the scanner, hold the probe in the air and press the null key. To adjust the liftoff angle, start the scanner and gently position the tip of the rotating probe so that it just grazes the surface of the standard. Press the angle key and adjust the signal so it points to the right. This completes the liftoff adjustment. Insert the probe into a fastener hole that has a defect. Press the gain key and set the gain as desired. Hold the probe steady, and while it's rotating over the defect, press the gain key 2 more times and then set the vertical gain until the signal reaches full screen height. Press the main key and set the scan RPM to the desired speed. If the scanning speed increases or decreases, the length function automatically readjusts the filter settings to compensate for any change in RPM, so you don't have to do any manual filter adjustment. As needed, press the main key again and choose between the figure 6 and figure 8 signal filters. The Nortec 600 features a new digital filter type that is capable of maintaining the 6 or 8 figure regardless of changes in the filter settings. This enables you to obtain identical signals and a consistent detection performance for every inspection. Variation in signal response due to differences between instruments is no longer an issue. When you have finished, press the full next key to display the signals in full screen mode. The default real-time readings display live vertical peak-to-peak amplitude and signal phase angle. This is useful for distinguishing genuine indications from non-relevant indications. In some cases, you may not have access to the surface in order to set liftoff. That's okay, because the signal phase angle can also be set while the probe is rotating in the fastener hole. When you do it this way, the liftoff is actually set based on the vibration noise. Make sure that you set the signal as flat as possible. This will provide you with a cleaner looking sweep display. The sweep display can be improved by adjusting the sync angle, which is available on the display menu. Finally, you can set the display to meet your preferences. Configuring the Nortec for steel hole inspection is very similar to the configuration that we just performed for non-ferromagnetic materials. You can follow the same steps you have just seen with 2 main differences. Less gain is required, and the defect signal comes up at a different angle. Just like with the non-ferromagnetic materials, pay attention to the liftoff angle. Make sure that you set it as flat as possible so that the sweep display produces a clean figure. We hope you enjoyed this instructional video on how to configure the Nortec 600 to inspect fastener holes. For more information on Olympus EdiTurn solutions, contact your local representative or visit us online at www.olympus-ims.com.